Okay, so thanks for coming to my talk. The name of the talk is different from the one on the placard, and I'm sorry about that. But you know, it's the dark arts of NixOS deployments. But more apt name is just tidbits and rants of NixOS from Carl. So you know, who am I? I'm Carl. I worked on Bitcoin Core for 3.5 years, and you know, I exited last year to work on consulting and all of those things like that. But that's sort of not very relevant. What is relevant is that I like operating systems. My idea of a fun time is installing Plan 9 on unsupported hardware. 9 front actually, not. And I guess my claim to fame, for perhaps in this crowd, is that I wrote the bitcoind service for Nix PKGs, the first version of it, and yet I understand that Nix Bitcoin has a better version of this service, and I also found a bug in this particular service a few weeks ago. So if you're having troubles, let me know. It's a one-line fix. Anyway, and also I worked when I was at Chaincode Labs on Bitcoin Core's build system security, and so I moved Bitcoin Core from a Gitian build system over to Geeks, and Geeks is basically supposedly a next generation of Nix written in Guile and everything. It's the sweatshirt that I'm wearing, and actually it's a main maintainer, a previous main maintainer, Ludovic, is, if you look at the Nix repo, the second or third most prolific contributor to Nix before he started Geeks. So Geeks was very good for bootstrapping things from a minimal trust base to a full compiler chain that's able to do C++ and everything. But Nix is very good for deployments and everything like that. So I'm here to talk about NixOS deployments. And I think one thing that I want to stress is I think NixOS is great for servers. And what I mean by servers is not physical machines or anything like that, although of course you can do. What I mean by servers is long-running services, right? So any of us who've run our Linux boxes have all had that experience of you have this Debian or Fedora or Arch box that you've been running for 3 years, and every time you touch it, you feel a little more dirty, Like there's just one more thing in Etsy that you've touched and modified in a particular way that you forgot to document, and now you have no idea why your system is acting the way it is, and it turns out you've installed, I don't know, OpenResolve and resolve-conf, and they're clobbering each other. I mean, that's just my life. I've done that 5 times, I think. I think that NixOS is really good for solving that. Right now, you have this one thing that you have to look at, and it's good. And I also think that it's really good for servers in a way such that using NixOS for servers and using NixOS to orchestrate services is really using NixOS for what it's good for. It's not good for, this is a mistake that I see a lot of people trying to introduce other people to NixOS does, is, oh, just install it on your laptop. Well, you tell a guy to install it on their laptop, you're going to run into, that laptop, gigabyte cheaped out on their wireless card and use this like killer card from like 2005 with no firmware support, and you have to do non-free or whatever, things like that. But if you use it on commodity servers like Supermicro or anything like that, or run it in a KVM slice, now you don't have those problems, and you can just get to what NixOS is really sweet for. What it's good for. Yes, and so for the first part of deploying NixOS is, of course, installing NixOS, and I've got absolutely terrible news. Nobody supports NixOS. VPS providers don't have first-class support for NixOS. It's not one of the logos you can choose when you spin up a new machine. And also, those who did have support are actively dropping it, because I am guessing people are running NixOS unstable and submitting customer support requests to their team, and they just drop it. So absolutely terrible. Don't do that, please. So how do we get NixOS onto, I'm on Vultr, maybe you're on DigitalOcean or something else like that, right? How do we get it into those machines? There are a couple of ways. One way is NixOS infect, and NixOS infect sucks, and the author of NixOS infect says so. It literally says in the README that if you use this, you'll probably brick your machine. Is because what NixOS infect does is basically you download a script that somebody else wrote and try to replace your file system in a very particular way and reload systemd in a very particular way in order to boot into something that works like NixOS. That is very terrible, very fragile, and of course that script doesn't work half the time. And so don't do that. The second way is to have custom ISOs, right? Like all these cloud providers, you're able to upload a custom installer ISO, boot from that, and sort of go from there. How you would install it normally on a computer, really. And for that, I would recommend you guys look into NixOS generators. NixOS generators is a really good project, part of the Nix community umbrella. By the way, I love the community umbrella stuff. It makes sure that things are somewhat well maintained, other than NixOps, but that's a different story I'll tell in a few minutes. NixOS generate is really powerful. I mean, it can generate images for Amazon, Azure, CloudStack, whatever. What I usually do is I generate and install ISO, just because I like to have more control over things. And you can install, and a good thing about generating and install ISO, a custom install ISO is that you can generate and install ISO with your SSH key pre-installed, right? So you don't have to do the dance of, I'm sure everybody's done this dance of, booting from the ISO and then having to go to your particular cloud provider's, view console thing and then log in via the virtual terminal and then change the password and then start OpenSSH and then you can go in and install, right? So being able to have like your own custom install ISO is really powerful there. Okay, so what's number three? Number three is sort of the dark arts, and this is sort of something that I discovered and I really love. And number three is kexec. What is kexec? So I don't know if you guys know the exec command. That's part of the POSIX standard. So the exec command says, okay, I want to execute this process with these args, but I want it to basically replace myself in the process tree. Pretend like I don't exist anymore and that I've just been replaced by this child, and I want it to inherit all of the file descriptors. I think it does inherit all of the file descriptors. What kexec does is basically it's like exec but for a kernel, which is really powerful in ways that I'll show later. A way to think of it, let's say, is that what we do reboot, or if you're a Leonard Pottering fan, systemd reboot or system control reboot, is we unload everything, right? Unload everything from the user space up all the way up until we don't have power anymore, and then we restart and reload everything back, right? So from the BIOS to the UEFI to the bootloader to the kernel to PID1 to user space to everything else. What we do with kexec is we don't reload everything. We just unload until we're at the kernel, and then we reload everything back. So that's really helpful for a bunch of stuff where you can have faster iteration. Basically, you can reboot without rebooting. You can clear kernel state without having to power it all down. And actually, there's another tool called soft reboot. This is from system control soft reboot that actually does sort of just the last two. But kexec is really the powerful one here, right? And so what kexec is really good for is two things. One thing that I was just talking about was installing NixOS, right? Being able to use kexec now means you can boot into a Debian image, right? and you can kexec now into a NixOS installer without needing to worry about, oh, does my box support Pixie, or does it support NetBoot, or does it support something else? You can just kexec into the installer and install it, and that's sort of the better way to do almost everything, right? And another thing that kexec is really useful for is to have rapid iteration of your, of your generations, right? One thing that I think a lot of people perhaps misunderstand or don't fully understand is that a NixOS rebuild switch. What NixOS rebuild switch does is it switches to the next generation, right? But without kexec, it can't switch to the next kernel version. So you're basically having this kind of, you're stuck in this weird state where your user space applications are at this new level, but your kernel is still at an older level, right? So you actually have to reboot in order to have the newer kernel. So what you can do is you can just kexec and you would have the new kernel without having to reboot your entire machine. NixOS rebuild actually has a flag called NixOS rebuild boot that says, don't try to switch to the next generation, just line up the next generation in your bootloader such that the next time you reboot, it becomes a new generation. And that's probably a safer way to iterate, right? So you might be thinking, okay, so what does it matter if there is a misalignment between my user space tools and the kernel? And it does matter. For example, I think back in 5.09, I think, is when the kernel added the in-kernel WireGuard implementation, right? And of course, an upgrade past that line and before led to a lot of confusion, right? Because past that line, now you have WireGuard built in, and it expects WireGuard to be built into the kernel. And before that, it was completely in user space, and that led to a lot of breakages in NixOS stuff. So using kexec in practice, I hope that people do use kexec in practice. I think it's really good for things like IP tables, things like IP tables where you have kernel state that you want to clear. I don't know about you guys, but I'm terrible with IP tables. And I always just add rules that I forget about later, or I make a mistake in my rules and I forget what's the exact -d invocation to clear this. What I do is I just kexec. I just kexec, and it's like a reboot without having to do a reboot, finishes in 3 seconds, and now I have a sort of a clear picture of what things do. So on UEFI systems, NixOS defaults to the systemd bootloader, which is a really simple bootloader that I hope everybody uses. And the systemd bootloader implements what's called the bootloader specification. The free desktop people always need to name things like it's the only thing in town, but it's a good specification. So the systemd bootloader it works really well with NixOS, because every time you call NixOS rebuild, it actually talks to systemd-boot and tells it, hey, here's the new generation, here's the next generation that I want you to boot to. And so whenever you do a rebuild and build a new generation, systemd-boot knows about that. And now when you do system-control kexec, it will ask systemd-boot, hey, what's the next generation that you want to boot to? And systemd-boot will give you it, and it will boot to the next generation. So that works really well on UEFI. Now, if you're on a BIOS system, and you most likely are. If you don't know if you're on a BIOS and an MBR system, you can check it pretty easily. But if you're probably on a BIOS system if you are in the cloud, in a system that you didn't configure, things like that, right? Because QEMU machines don't default to UEFI, unfortunately, which I think they should. If you're on a BIOS system, then you can't run, or it's very hard to run systemd-boot. You need something like refind or something like that that emulates a UEFI. So you probably use grub as your bootloader, which sucks. I mean, anybody who's touched Grub and its shell scripts will know that it kind of sucks. So I think actually a fantastic hackathon project, if anybody's up for it, is integrating NixOS rebuild with Grub or with biosystems or with the kexec command line, such that kexec works on biosystems. It should be 10, 20 lines, but you got to spot where to put it, I think. Cool. And so with all these tools, there's a project called NixOS Anywhere. And NixOS Anywhere is very cool. NixOS Anywhere uses kexec, so if you just have a Debian box with an SSH connection to it, it will basically SSH into it, kexec into a NixOS installer, and run your installation scripts, which is really cool. And it does the disk partitioning with a tool called Disco. And you guys should all check out Disco. Disco is very cool. Apart from having a great name, it also allows you to declare your disk partitions using a declarative nix expression, which is really nice because I feel like if you've installed enough systems, you know that like the disk partitioning and formatting is one of the most annoying parts, let's say. And I sometimes fat finger percentages and all that. And also, so it uses Disco, so it knows how to format all of the disks. And this is just a tip from Carl, just maybe more of a note to himself, is just use LVM. It's never worth it to write raw partitions because you're going to get the order, you might get the order of the root and the swap partition wrong, and then you expand your disk, and then you have to do the magical dance of how to swap them again so you can expand your root partition. Don't do that, just use LVM. The performance hit is negligible, and you'll thank yourself later for it. Future you, yes. So, you know, we've set up our machine, right? We've set up a NixOS machine. So how do we deploy configurations? And this is sort of how I feel about deploying configurations since getting burned. I think I used NixOps for a while, and then it was abandoned for a NixOps 2.0 that never happened. And now if you run the 1-point-something branch, it's all insecure dependencies and everything, so nothing works. And then I've tried other things that try to do magic rollback and everything, and nothing really works. But this year I found my new love, and my new love is NixOS rebuild. And this was from this post by Haskell for All, right? Very typical of a NixOS lover, announcing NixOS rebuild, a new deployment tool for NixOS. But I mean, I'm sure everybody has used NixOS rebuild before, right? Like that's the NixOS rebuild switch is the first thing that you learn in NixOS. And what you can do with NixOS rebuild is you can give it a flake. It works with flakes. You can give it a flake of your configuration and tell it to deploy to this target host and build with that target host. And with that, I know it's blasphemous. I'm using a Mac right now. I actually deploy to 5 or 6 NixOS Linux servers from my Mac. It works really beautifully, and it doesn't require installing any tool that might be mismanaged, mismaintained. And so if you have a simple configuration, this is really good. Just write a bash script that does this. Cool. And the next thing I want to talk about is systemd-creds. Systemd-creds is mostly in a light of not like you should use this right now, but in that this is really promising and it needs like one little tweak, and perhaps this is just me being idiosyncratic, but you know, this just needs one little tweak before I think it's really ready for prime time. So where did systemd-creds come out of? Systemd-creds actually came out of the NixOS, well, okay, let me give some background on why secret management is sort of not a shit show, but a difficult problem in NixOS, let's say. NixOS is all about declarative deployments, right? You declare everything, right? And this declaration is world readable, which is great in terms of interoperability and everything, but terrible in terms of secrets, right? You don't want all of your services to be able to see all of your secrets. And so there has been, long-standing, all of the deployment tools I've talked about before, I mean, they use different ways of getting secrets across, and all of them are broken in very specific ways. And so NixOS, there was a general discussion in the NixOS GitHub repo about secret management, and Leonard Pottering, the maker of all your nightmares like Pulse Audio and systemd, chimed in, and he was like, okay, I'm just going to build this tool called systemd-creds, and it's going to solve a bunch of the stuff. And it has some really cool, it really does have some really cool properties, right? So in systemd-creds, you're able to supply specific credentials to systemd units because it's aware of the units, right? So now you don't have to do system credential passing through environment variables, because passing it through environment variables means that all of its child processes also get these secrets, which is perhaps not something that you want. You can actually mount secrets to the particular file system namespace, almost like a container, of that specific unit and not share with anybody else. It's also designed such that it goes, the secrets are mounted via ramfs instead of tempfs. And ramfs is a file system that resides in RAM but cannot be swapped out, which is fantastic because if you swap out your secrets from RAM to disk, then you're basically leaking it, unless you have encrypted swap, I guess. So yes. Right, and another cool thing about systemd-creds is that its encryption uses a per host key. So it uses a key that's assigned to one host, and it also knows how to use the host's TPM if it's available. So for those of you who don't know what a TPM is basically like a hardware wallet for your computer, and it exists in most computers. Your computer probably does have a TPM, and it has fused keys inside where you can never get the private key on, much like a hardware wallet, right? So systemd-creds knows how to encrypt secrets to that TPM such that if that computer was destroyed or the secret gets elsewhere, it would be completely useless, which is really cool, and it limits the risk of lateral movement between the hosts as well. Right? So what's it like, right? Like how can we use this? How can we use systemd-creds in NixOS? What's the adoption like? So systemd-creds is currently already used in about, if you just search on nixpkg like I did this morning, it's already used in about like 35 modules. Different services are using them, mostly for passing credentials between services. So you can think of it like, for example, if you have a bitcoind that has like a cookie, how do you pass that credential securely to a C Lightning or an electors or something like that needs to use that credential, right? From the NixOS wiki, they also have examples of how to use systemd-creds in order to have Acme give OpenSMTPD credentials in the format and in the permission model that it wants. However, I would encourage people to read this NixCon 2020 talk by Corfuri about how systemd-creds can be a lot better, especially in terms of encrypted systemd-creds. Right now, systemd-creds encrypts its secrets using symmetric encryption, which is somewhat terrible. It means that if you want to encrypt a secret to a machine and not between units on a machine, you want to encrypt a secret to a machine, you need to SSH into it, encrypt it, and then get it back and then put it in your config, which kind of sucks. It would be much nicer if systemd-creds implemented asymmetric encryption so you can have the machine key, encrypt it locally, and just deploy, right? Like that would be much nicer, and that's like sort of the only thing that I see that systemd-creds needs before everything is good. Cool. So thanks everybody for listening. I've got a lot of other extra facts, and you can come talk to me about it and everything else. And I would love to hear questions, although I know we're tight on time. Thanks.
Hey. So how would you compare systemd-creds to, for instance, SOPs and nix-sops, SOPS?
Right. I haven't really used SOPs because, you know, I think it. Wait. Is it the one that used GPG or SSH host keys?
You can choose.
Okay, you can choose. Okay.
You can choose, and if you're using the SSH, actually, it's going to be AGE's support for your SSH ED25519 keys.
I see. I think I'm sort of, perhaps a lot of people don't agree with me on this, but I think the systems layer needs to have some layer violations. And so I think this is why I'm somewhat of a fan of systemd. I know that I'll get butchered for this. But I think the systems layer needs to know things about each other, right? And I think that systemd-creds can know about which unit is executing and which unit is requesting the things, which allows for a higher level of security than just sort of key-based stuff like SOPs. So I would hope that this line of work continues and that, you know, other distributions are interested in it, silver, blue, and all of those things. Yeah.
Anyone else?
About the asymmetric encryption in systemd-creds, isn't that the limitation of the currently used TPMs, or do current TPMs allow asymmetric encryption?
You're talking about VPNs? TPMs. Yes. Right. Yeah. Yes, there will be constraints by the TPMs. Perhaps maybe the 1-point-something spec doesn't have asymmetric encryption, but I think that there is work to, I think 2.0 does have asymmetric encryption. I have to check again, but I think there's actually a to-do list item on the systemd main to-do that's like, okay, implement the new TPM asymmetric encryption thing, which somebody please do that.
Yeah, thanks.
Talking about bare metal deployment, one thing that's maybe interesting would be like firmware updating, or like we have, what is it, LVFS, and it'd be cool to say like, oh, here's this bare metal thing, I know what machine it is, but like also reflash firmware to like, maybe not latest, but like some pinned installs there. Does that sound like that could be mixed into these tools, or? Yeah. This is sort of why I think NixOS is best in an emulated, in a virtual environment and all of those things, right? Because like that's like an additional state, that's an additional impurity, basically, right? Like if you think about it in NixOS terms, it's an additional impurity because it's not like you can make a NixOS configuration and then change the firmware and then be like, okay, well now this deployment is going to downgrade the firmware of your hard drive or something like that. That would be perhaps somewhat worrying. So a architecture I've thought about recently, and Jonathan, you've actually inspired me to do this, is to have Proxmox and then just run a bunch of NixOS things on Proxmox with VirtIO and IOU ring and everything, so it's performant. So.
No. Anyone else?
Cool. Thank you, Carl. Let's give it up for Carl. Yeah.